Alright, so let's just run through a quick example here of a proof by induction question which you might be given. So I've taken this question from a textbook. Prove by induction that 9 to the power of n minus 1 is divisible by 8 for every n in the this is the positive integers, and we sometimes just call it the natural numbers. This is where the abbreviation comes from. These two symbols, you'll come across them in university, but for now you don't really need to worry about what they mean exactly. Uh, you'll see one of those two symbols. In either case, that means the numbers 1, 2, 3, 4, 5, 6, 7, 8 up to infinity. So, what's the first step of proof by induction? Is to show that it holds for n equals 1. So we plug in n equals 1 here. 9 to the power of 1 minus 1, that's just 9 minus 1, that's 8. And 8 is clearly divisible by 8. So this statement in the question holds for n equals 1. Simple as that. Then we have our assumption step. We assume that we're given some integer k for which 9 to the k minus 1 is divisible by 8. Right? So this integer could be 1 because we've just shown that 9 to the 1 minus 1 is divisible by 8. It could be any other integer for which we know the statement holds. Let's say, or I mean not let's say, now our job is to show it for 9 to the k plus 1 minus 1, so k plus 1, right? We know it for k, we want to show it for k plus 1. We want to show that this is divisible by 8. And we can do that through some manipulation. So first we write out the expression, then we write 9 to the k plus 1 as 9 multiplied by 9 to the power of k. And next we write out 1 as 9 minus 8, right? 9 minus 8 gives us 1. Now, you might say, oh, come on, this is just silly. Why are we writing out 1 like this? Nobody writes out 1 like this. But we have a reason. We see here, we're given that 9 to the k minus 1 is divisible by 8. And we want to show that 9 to the k plus 1 minus 1 is divisible by 8. So our life would be made much easier if we're able to use this assumption here, that 9 to the k minus 1 is divisible by 8. And if we look here, by changing the 9 to the k plus 1 to 9 multiplied by 9 to the k, this number in the brackets is very close to what we need. If we get 9 to the k minus 1 here, then we know that this bracket would be divisible by 8, and then anything that's divisible by 8, whatever integer we multiply it by, that whole thing is also divisible by 8. So when we write this out as 9 minus 8, because we can move this 9 into these brackets. You see, this negative sign makes the 9 negative, and so we move it here. That's why here we write out precisely 9 minus 8 and not 10 minus 9 or 12 minus 11, right? So we do exactly this. The negative sign makes the positive 9 negative, and we move it over to this bracket, and then the two negatives make a positive, and we get plus 8. Then we factorize out this 9, we take it out of the brackets, and we get 9 multiplied by 9k to the minus 1. And now we have something that's divisible by 8 in these brackets multiplied by an integer, which means that this whole thing on the left here is divisible by 8. And then we're adding 8, which is clearly divisible by 8. So this whole expression is divisible by 8. And this whole expression here over on the right hand side is equal to the expression on the left hand side. So we've shown that this thing on the right is divisible by 8, therefore this thing on the left is also divisible by 8. And this is what we write out here in this sentence. So we know that this is divisible by 8, and so when we add them together, we have that the case for k plus 1 is divisible by 8 as well. Now, finally, we want to show this conclusion here. So, in my video on proof by induction, I asked you to sort of explain this proof in a few sentences, and I'm going to try and do that here to explain the proof by induction. So, here I've given a simpler statement, which is just 3 sentences, which you can use and it will suffice. But I'll give you a complete. So at the end, we cheat here by mathematical induction. The statement holds. This is not. This is enough for your exam, but it's not really good enough to sort of explain the mechanics through which this proof holds. So I'm going to explain it fully. So we have shown that the statement holds for n equals 1, and we have that if the statement holds for k and z plus, then it holds for k plus 1. Therefore, this relationship, plugging in letting k equals 1, shows us that the statement holds for 2. Now that the statement holds for 2, we can also let k be equal to 2, in which case the statement holds for 3. Repeating this process infinitely many times, we get that the statement holds for all integers. So you get the point. It takes like 4 or 5 sentences to sort of explain the whole process. But if you just write by mathematical induction, that's good enough. That's what in my exam at least. Obviously, talk to your teacher. Ask them if this conclusion is good enough. If you're in doubt, but this, in my exam at least, worked, and this is essentially what I wrote, and it worked for me. And at university level as well, this is good enough at university level to get the full marks. So I hope you understand how the proof works, and I hope the example was useful, and I'll see you in the next video. Thank you.